When you look up at the sky at night, what do you see? A vast expanse speckled with the bright lights of far-off stars. A gateway to the rest of the universe, the endless void of space. But we know that lurking within that vast expanse, cloaked by that endless void, there are huge, potentially world-ending masses. Our eyes can't register them, and even our most powerful telescopes have traditionally struggled to pick them up. But they're there, and in greater numbers than we've ever seen before. This is Unveiled, and today we're answering the extraordinary question: did scientists just discover 1.2 million black holes?
Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one and ring the bell for more fascinating content?
In 2021, we're no longer mapping just the stars in the universe. We've moved on to bigger and more brutal things: black holes, supermassive black holes. And at the heart of today's video is one especially startling map, the details of which were released in late February 2021. It reveals the locations of 25,000 supermassive black holes. But what's even more mind-boggling is that it only covers 4% of Earth's northern sky, which means 2% of the sky in total. It suggests then that were we to chart the rest of the sky in the same detail, we'd be looking at 1.25 million supermassive black holes. But let's scale back a second. Where did this incredible map come from? It was produced by the Low Frequency Array, otherwise known as LOFAR. LOFAR isn't just a single telescope, but a network of telescopes, based in Europe and primarily in the Netherlands. The network spreads across 9 countries in total, though, covering an area of Earth with a diameter of more than 600 miles. And it's set to grow even bigger still, with sites opening up in more and more countries in the future. In some ways, LOFAR can claim to be one of the biggest telescopes on the planet. At present, LOFAR consists of more than 50 stations housing around 20,000 antennas. As its name suggests, it monitors the sky at low-frequency radio wavelengths. In the past, it's proven difficult to generate a detailed view of space from the Earth's surface at low frequency because our planet's ionosphere gets in the way and distorts the data. But LOFAR gets around this by digitizing the signals it picks up. It then transports them to a digital processor where the distortions are ironed out, resulting in the crystal clear visuals we have today. And the supermassive black hole map is certainly clear. In fact, it's dazzling, and could easily be mistaken for a star map. But all of those bright spots really are black holes. All of them represent a supermassive black hole that's active, meaning it's probably at the heart of a galaxy ruthlessly devouring matter. Of course, not every supermassive black hole is particularly active. Some lie as though dormant and are quieter, and the LOFAR map may not have charted these, seeing as they give off far fewer signals. So another incredible aspect to this map is that there are still more black holes to add. It's easily the most comprehensive collection of black holes we've ever produced, but it most likely still isn't everything. Can we truly say then that the LOFAR map serves to reveal more than 1 million black holes in total? Literally speaking, it doesn't do that. It reveals to us, with greater clarity than ever before, the number of black holes within just a small portion of the sky. It doesn't show us the whole sky, but the plan is that one day it will. The pioneering team behind LOFAR has high aims for the LOFAR LBA Sky Survey, a broader study seeking to chart in detail the whole of the northern sky. It won't only map black holes either, but could be a crucial project in helping us to understand exoplanets, quasars, cosmic rays, and the inner workings of galaxies. The 25,000 black holes revealed so far, then, could be just the beginning, and expectations are that we'll soon be peering even deeper into the universe across an even wider area. But what does all of this mean for us? And why, in recent years, has science news been so stacked with black hole updates? For some, there are bigger and more pressing problems for us to worry about. But for others, it doesn't get bigger than black holes. Supermassive black holes can have a mass billions of times greater than the Sun. We're not entirely certain exactly how they form, but that are the site of immense gravitational collapse, and they can be found at the center of most large galaxies, including the Milky Way. Thanks to the gravitational influence they wield, they're variably described as being like linchpins of the universe, holding it all together. And according to some end-of-the-universe theories, they could be the last things that remain along our cosmic plane, and it could take trillions of years for them to finally disappear. Seeing as they're such an ever-present then, scientists are always keen to learn more about them. Back in April 2019, the first ever photograph of a black hole made headlines around the world. The now iconic image shows the supermassive black hole at the center of the Messier 87 galaxy, an elliptical structure some 53 million light-years away from Earth. In March 2021, an updated version of the image was also released, detailing the black hole's magnetic field. Like the black hole map, the photo was also captured using a network of radio telescopes, an array known as the Event Horizon Telescope. And the EHT spreads wider than even LOFAR does, with stations in more than 20 countries and across multiple continents. Both projects show us how huge an undertaking it is to even begin to understand black holes. But we're clearly making rapid progress as we move through the 20th and 21st centuries. Mere decades ago, we knew nothing of black holes. The term itself only came into use in the late 1960s. And while they had been seriously theorized since the early 1900s, it wasn't until 1971 that the first black hole was actually discovered, Cygnus X1, about 6,000 light-years away. Now, we've got 25,000 of them pinpointed in space, and we know there are countless more waiting to be found. It's estimated that there could be millions, perhaps even billions, of the smaller stellar black holes in just the Milky Way galaxy. It's also been predicted that there could be multiple trillions of galaxies in the universe as a whole. So for stellar black holes, that's just an eye-watering number. But even for supermassive black holes, if there's at least one at the heart of most galaxies, that means there could be trillions of them out there. And suddenly we see that even the LOFAR map, as undoubtedly brilliant as it is, barely scratches the surface. Black holes, it'd seem, are everywhere, but there's still no cause for immediate concern. In April 2021, scientists discovered the closest black hole to Earth we've yet found, and named it the Unicorn. But the Unicorn is still 1,500 light-years away from us, and it's relatively tiny, at just 3 times the mass of the Sun. In black hole terms, it's one of the smallest we've ever recorded, and there is still a considerable distance between us and it. At the time of writing, it's still classed as a black hole candidate, with its small size being a major reason why astronomers can't claim with certainty that it is a black hole. But regardless, the Unicorn shows just how crammed full of black holes space probably is. Remember, the LOFAR map shows supermassive black holes only. It focuses on the greatest and biggest examples out there. The supermassive black hole at the center of the Milky Way, for example, is more than 1,000,000 times the mass of the Unicorn. Imagine then what a black hole map would look like if all the smaller ones were included as well. For now, we can definitely say that scientists have charted 25,000 supermassive black holes across an area that's 2% of the Earth's sky. We could then calculate that to mean 1.25 million supermassive black holes across the sky in total. But in reality, not even that number comes close to the number of black holes in general there are in the universe. At one time, these things were thought to be rare, roaming through space in an ominous way. But now we know that they're not rare. There are many, many thousands, millions, perhaps billions of them in existence, but they're also not especially threatening to us. And the closest one to Earth we've ever discovered is still tucked safely away, some 1,500 light-years in a different direction, all of which means that we can view the LOFAR map with wonder rather than worry. It truly is one of the most impressive images of modern science.
What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.